wrapping up our discussion about occluded fronts. So just a thing to remember with occluded fronts. At both the cold front occlusion and a warm front occlusion, we still have warm air getting forced aloft. So we can go back to this picture here. We still have warm air getting forced aloft in both of these scenarios. And the problem with this is that it's going to create a lot of cloudiness, it's going to hide thunderstorms, it's going to create a bad type of weather. It's the worst type of front to have to cross. An occluded front is going to create the worst weather patterns. Now, it's the character of that warm air sector as it gets lifted, its stability, its moisture content, that's really going to determine what weather happens at the front. Okay, so another special case that can happen. It's called the winter warm front. So the winter warm front. If you're heading west in the winter toward what we call a winter warm front, you are going to get a warning of some things to come. And we can cue that scary music up. What we are going to see as we head west toward that front in our airplane, we are going to see that we have our freezing level right here. The next thing that's going to happen is we get air that gets forced aloft. We have advancing air as that warm front advances. What's going to continue to happen is we have snow that starts falling from above. That snow starts falling. As we get farther, closer to that warm front, we end up with some freezing rain because we have cloud development that has developed along this advancing warm front. In this area here, we're going to have some precipitation start falling. As it falls, it becomes super cooled. As it gets into this cold air ahead of the warm front, it can then start freezing as it hits our airplane. This is obviously very bad, especially for light general aviation aircraft. The good thing is that we do get a warning. So if we are encountering this ice pellets falling out of this, again, we have this moist air creating precipitation. As it falls, here it's going to be in that cold air long enough that it stays cold and forms into ice pellets. So these things are going to bounce off of our airplane. In this region, we are going to just see rain as we approach this winter warm front. So here we have our rain, here we have our pellets, here we have freezing rain, and on this side of things we have just snow. Snow is falling out right down there. So the danger for us as airplanes, so here's our small airplane as it approaches. The first warning that we're going to get of one of these winter warm fronts is rain. So we are going to get some rain. That's our first warning. If we know from getting a weather briefing that there's a frontal activity, there's a winter warm front, and we're flying toward it, we need to be aware of that. And as soon as we start seeing rain, that's the time to find a place to land right where we are, or turn around and go 180 degrees away from that winter warm front and get landed. The reason is, if we continue to fly, we're going to start encountering ice pellets. These are going to bounce off our airplane. But as we continue, if we continue, we are going to encounter freezing rain. Light general aviation aircraft, and even aircraft that are general aviation and equipped with some anti-icing systems, aren't going to be able to survive a bad encounter with freezing rain. So what's going to happen is bad stuff. If we continue on in this bad path of things, we are going to possibly have an accident caused by icing, which would be unfortunate for us. So the solution for a light general aviation aircraft is to not do what this person did. Instead, as we start encountering rain, we're flying toward our winter warm front, we start encountering rain, I want you to turn around and go land over here or go land right here. Do not keep going until we get to the pellets and the freezing rain, because that could prove fatal. So you need to be aware of the winter warm front, how to detect these things, what to expect with these things happening. What's going on aloft is we have that thermal inversion with Another kind of special case to talk about here as we wrap up the discussions of fronts and air masses is something called the dry line. It looks like a little line of D's. D for dry, D for dry line, okay? So here is the dry line, little D's. These are of concern for us, especially in the state of Texas. Some in Oklahoma a little bit, but dry lines. Whoop. Okay, let's go the right thing. All right, a Marfa front is another name for a dry line. So a dry line is exchangeable with Marfa front in terminology. This is because of the West Texas town of Marfa. Here's a picture of Marfa. Marfa just happens to be where a lot of these dry lines tend to form. It's also known for something called the Mystery Lights at Marfa. Don't know anything about it, would like to go see it. If you've seen it, I'd love to hear about it sometime. But Marfa front, dry line. So basically what happens, it's also sometimes called a dew point front. So now we got 3 names, if that isn't confusing enough. Dry line, Marfa front, and dew point front. The dew point front is probably the most descriptive of these names. We have dew points varying significantly on either side. For me to see one, let's zoom in on this side. If we take a look here, we have a situation where we have warm, moist, maritime tropical airs coming up from the Gulf of Mexico on the eastern side of Texas, where I live in East Texas. You can see here from our dew point models, these are in Fahrenheit. We have 72 degrees dew point, 68 degrees in Dallas looks like, maybe 66 degrees in College Station for the dew point. Now, if I look on the west side of my dry line, out in western and central Texas, I'm going to see up in Amarillo, we got 36 degrees Fahrenheit dew point. We've got 34 degrees. Maybe 31 is Abilene. I'm not really great with my Texas geography. But we have a lot lower dew points on this side of this dry line, or dew point front. So it is a narrow boundary where we have a very steep horizontal change in moisture because we have this rapid dew point temperature change across this very narrow little distance. So here we have a dry line that can move across Texas and Oklahoma, and it generally is separating our warm, moist air coming up from the Gulf from hot and dry continental tropical air coming up from the deserts of Mexico. Where we have potential instability is because we end up with warm, dry air coming up above warm, moist air. And as air rises, we have instability, and if we have instability in the atmosphere, we can create thunderstorms and cumulus clouds. This situation, this dry line here, this often behaves a lot like a cold front in the fact that it can generate severe thunderstorms. Here's just an example. Common in the spring and summer months in Texas and Oklahoma. I have seen these as late as the fall, but more common in the spring and summer months. Generally, the dry line is going to advance eastward during the daytime, and then it generally retreats back westward at night. It can last for quite a few days. So here we have humid air that comes up from the Gulf, flowing up into East Texas, flowing up into central East Texas. But then we have this dry air that's coming up from Mexico, and we have this narrow boundary of change, and that's our dry line. Now, when this happens, all my drawing stayed on there. When this happens, here's our dry line. It's drawn on the weather map. And this is an example right here of where you end up with tornado outbreaks. So here's just an example from space. Here's a dry line overlaid on a satellite view. And this was actually responsible for a large tornado outbreak in May of 1999. And these things have been responsible for multiple tornado outbreaks across Oklahoma and Texas. So that is the final kind of specialized front, the dry line, or the Marfa front, or the dew point front, whatever you want to call it. So just realize it acts kind of like a cold front in its behavior, and it separates air that is moist and wet and hot from hot and dry air on the other side of Texas.